Hello everyone, welcome back on CLARI concept. In today's session, we will discuss rotary balancing method. For better understanding of this topic, watch second lecture. So let's start. To understand rotary balancing, take some real life example. So here I am taking car with wheel which rotated at high speed on road. But in second figure, you can see that wheel is rotating along with that vibrating or shaking. By viewing this, question in your mind rise that why this happening? Reason behind of this unbalanced mass or non-uniform mass take place major role which create unbalanced force and movement or couple due to that your wheel is rotating along with that vibrating at high speed. Now another question in your mind that how will I know that my wheel unbalanced or how much mass I have to kept? So for that balancing machine use which show required mass to make your wheel balance by the computer. Here you can see that a green spot on tire which shows unbalanced mass and due to that unbalanced force created. To remove this one clip added of metal which make your wheel balance. It means your unbalanced system will be converted into balance by this metal clip. This method is also known as a wheel balancing or wheel alignment, and this method we do when we change tire or a puncture tire use in for the long distance. Now take another example which is a turbine. You all have seen that turbine has a number of blades with different size and different shapes. But when any one blade breaks or bends, at that time turbine produces jerk, noise and vibration along with the rotation. This shows us that there are some unbalanced force and couple because of unbalanced mass or non-uniform masses. To remove this unbalanced force, we add some extra mass on the bent blade of turbine. If your turbine blade breaks, then we have to change it. Here you all can see that yellow color shows blade of turbine in which some of blades get bended. To remove effect of that, we will add some extra mass in form of red block metal to make turbine perfectly balanced. Here take one shaft on which rotor is placed and both are rotating by help of motor. Here you can see that rotor not only rotating but along with that it's shaking. A shaft is rotating and object on that also with help of motor. But why does it shake or vibrate? Because center axis of rotor and centrifugal force produced by non-uniform mass axis not coincided. At that time that produce unbalanced force and make your system unbalanced. There are so many questions in your mind such as how does a place extra mass to balance the system? There are four methods to add or remove the mass from the system. One is a balancing of a single rotating mass system by a single mass rotating in the same plane. Second one is a balancing of different masses rotating in the same plane. Third one is a balancing of a single rotating mass system by a two masses rotating in the parallel plane. And fourth one is a balancing of different masses rotating in the different plane. In this lecture, we will discuss only first two methods, and in the next video, we will discuss another two which remain. Before we learn about methods, first discuss about the solution method. So there are two methods in rotary balancing. One is a graphical method. In this method, we will draw and get answer. Another one is a analytical method or analytical approach. In this, we will solve mathematical equation to get answer. So let's start with first method of rotary balancing, which name is a balancing of a single rotating mass system by a single mass rotating in the same plane, or you can say static balancing of rotor by adding or removing the one mass in the same plane. To understand this method, take one shaft on which one rotor is placed, and the blue color rectangle shows plane of that system. On this plane, one mass m which placed with radius r. Due to this, mass centrifugal force produced. This force is unbalanced force. To remove this effect, we have to add some extra mass. To understand how to add mass at which angle, see this. Here I am taking one rotor which placed on one shaft. There is a one unbalanced mass m1. To remove its effect, adding another extra mass m2 in opposite direction. From the center of the rotor, this mass is placed with radius r1 and r2 respectively. Now one question in your mind, that why did I keep extra mass in opposite direction? So to understand this, take one real life example. When you fly a kite, at that time if kite fly in left direction in the sky, then you add extra force in the right direction to make your kite stable in the sky. That the same concept used in the balancing of same plane. As we talk, there are two methods to solve any rotary balancing problem. But here we talk about same plane, so no couple or moment produced. Now first talk about graphical method, in which your polygon should be closed to make system balance. But in our case, only one force is balanced. To make it balance, we added one extra mass which creates some forces. Due to this both forces, polygon can't be closed. It will be only one line. For that, we will talk only about analytical method. So in the analytical method, sum of all forces should be 0. First take system mass which produce centrifugal force. It is m1 r1 omega square is equal to F. Now add centrifugal force of balance mass. It means m2 r2 omega square. When you generalize this equation, you will find omega square in both the terms which cancel each other. So your equation will be m1 r1 is equal to minus m2 r2. This equation shows you that your balance mass should be equal to the m1 r1. If your mass is smaller than m1, then your radius should be greater than. It means m2 is small, then r2 should be greater than, and if r2 is small, then m2 should be greater than. So here we have talked only about forces. It means when you talk about only force and no couple is talked, then it showing you your system in a static balancing. The first case of our rotary balancing system is static balancing. So now talk about next method of rotary balancing, which name is balancing of different masses rotating in the same plane. But here also all mass is kept in the same plane, due to that no moment or couple produced in graphical or analytical method. But why we need this method? Because if your system structure is complex or less spaced, at that time you can't place one mass in one position. For that you have to keep different masses in the same plane at different position. Let's take one rotor on shaft. In that one plane is which three masses placed. By viewing from the side view, masses kept with different angle and radius. As you can see here, mass m1 is placed at radius r1 from the vertical in clockwise direction at theta 1 angle. Same thing, a mass m2 is placed at radius r2 with angle theta 2 from the vertical axis in the clockwise direction, and the mass 3 is placed at r3 radius and theta 3 angle from the vertical axis in the clockwise direction. These masses create unbalanced force in the system. To make your system balance, you have to add extra masses. Here I am adding only one extra mass in the system, but your system has not space. then you have to put extra mass in the system. It means you can put more than one mass. First we solve this method by graphical method. In this first row force polygon due to mass m1 in the system produce unbalanced centrifugal force m1 r1 omega square. But here omega square is common term in the all masses produce force, so remove it, so that force will be only m1 r1 by mass m1. The same concept used for mass m2 and m3, so that force will be m2r2 and m3r3 respectively. Now draw a vector in the direction of centrifugal force produced by mass m1, and the length of this vector should be equal to the magnitude of centrifugal force by the mass m1. The same concept is used for the mass m2 and m3, and their force will be m2r2 and m3r3. But by drawing these three vectors, you can see that polygon is not closed. To make system balance, your polygon of forces should be closed. So draw vector which make polygon close, and this vector length shows magnitude of centrifugal force produced by extra mass to balance your system. From that you can say that put some mass m at radius r and angle theta from the vertical axis in clockwise direction, so that your system should be a. Now solve method 2 by analytical approach. Before we start, I want to tell you that analytical method is more accurate compared to the graphical method. So use more analytical method if nothing is mentioned. To solve by analytical method, first make one table in which mass, radius, angle and force cover up. Here first take mass m1 which place at radius r1 and theta angle. So by that produced force will be m1 r1. Here omega square removed from all the terms. Same concept used for all other masses of system and for the extra mass. So here you can see I have written for 3 mass which is in the system, and the extra mass m which placed at radius r and angle theta, and it produces force mr. But here you can see you don't know value of m, r and theta. It means you can see from the table there are 3 unknowns. From the figure, you have seen that every mass placed at different angle. Due to that, produce centrifugal force at different angle, for that having two components in the x and y direction in form of cos theta and sin theta. From the table you can see that there are components of every mass placed in the system, like m1 mass at r1 radius and theta 1 angle, which produce force m1 r1. But this m1 r1 force produced at theta 1 angle, therefore it having two components, which is m1 r1 cos theta and m1 r1 sin theta. The same concept we can use for the all masses. The all masses means 3 mass in the system and 1 extra mass you have added to balance the system. The number of unknowns which m, r and theta we have to find by using analytical condition. First, apply condition that sum of force in x direction should be 0. It means sum of component of force in terms of cos theta should be 0. But here mr cos theta is unknown, so that move this term in the opposite side of equal to and give name to this equation as a. Same thing for sine component of force and give that equation as a name b. Take ratio of equation b by a, so that in the left side you will get some value and in the right side you will get tan theta where MR is cancelled out to each other. By inverse of that tan inverse you will get theta's value. Now this theta value you can put in equation A or B. Here I am taking equation A. When you put all values, you will find value of Mr, which is a centrifugal force produced by mass M, which is a balance force for the system you have to add to convert your system from unbalanced to balance. You to watch this video. See you soon.